Today is 19 May of 2021. Very good morning and welcome to Breaking News with Nila Anatsilo. What is mercury? Mercury is considered as a serious toxic heavy metal to both humans and the ecosystem. It is freely distributed throughout production, processing, transportation, and consumption systems. Okay, there is a case study about mercury issue in oil and gas industry. Let us watch the video.
As a team of chemists and chemical engineers in Petronas, our aim is to achieve sustainable health, safety, security, and environment performance and ensure everyone goes home safely.
Hi Ms. Andrew, it's been great to meet you today. A bit urgent, may I straight go into the topic? Okay, sure. Okay, cool. Today I just received a call from my colleague at PSC site talking about the light level of failure of our aluminium cold box in one of the heat exchanger happened in area A. So through the investigation, it's still under the investigation, we found several clues that shows that this aluminium cold box degradation is caused by the mercury. Today I bring along my project team, Samini and Nitya, as the chemical engineer over there to explain to you what is the mechanism behind and what is the treatment that we can do from prevent it happen again. Alright, starting with the first mechanism, amalgamation.
Amalgamation is a process by which the mercury reacts with susceptible metal, in this case aluminium, to form the metal amalgam. Generally, aluminium is prevented to contact with mercury due to the layer of oxide above it. Even though the oxide of aluminium contains numerous defects, mercury still couldn't penetrate it due to its high surface tension property. Unless there is thermal or mechanical stress or chemical environment that remove the oxide layer. In this case we add the hydrochloric acid on it, and the hydrochloric acid will react with aluminium oxide to form aluminium chloride and the water. So right now the aluminium is free to react with the mercury to form the amalgam. Let's watch this short video to see how does the amalgamation of aluminium looks like. In the end, you can see the result will turn out the surface etching and pitting and also loss of the mechanical strength in aluminium.
Then we move on to the second mechanism, amalgam corrosion.
The second mechanism of aluminium degradation is amalgam corrosion. Amalgam corrosion is the combined reaction of mercury and moisture on aluminium. It's similar to amalgamation, but the difference is there's presence of the water. Through the equation, we can notice that the aluminium amalgam will react with the water to form aluminium hydroxide, hydrogen, and mercury. The presence of bubble indicates the presence of the hydrogen, and the product of the mercury will react again with the aluminium to form the aluminium amalgam.
Through the equation, we could notice that the amalgam corrosion won't consume any mercury. It will be self-propagating as long as the sufficient of water is present and the mercury is in contact with the aluminium. The result will be similar to the amalgamation, but the difference just it will be unlimited as long as there's enough water in it. Then we move on to the third mechanism, which is liquid metal embrittlement.
Liquid metal embrittlement is the normally ductile metal become brittle when stressed in contact with molten metal. I will use this example to explain the details of it. Okay, so we straight jump into the stage 2, when the liquid metal, which is the zinc liquid, in contact with the susceptible metal, which is in this case is the iron. Under the stress, it will diffuse along the grain boundaries of the iron. In step 3, we could see that the drain boundary are open due to the tensile stress. And moving on to the stage 4, the penetration of the liquid metal will continue by capillarity and cause the further cracking. So we can see for the stage 5, the cracking is still continue, and the liquid metal atoms, when absorbed on a susceptible metal, it will reduce the metal bond strength within the grain boundary regions of the susceptible metal. In the end, it will result in absorption-induced cracking.
Alright, Mr. Andrew, I hope you can understand the mechanism behind the aluminium degradation. Later, my colleague Ms. Samini and Ms. Nitya will explain more on 5 treatments on how to do the mercury decontamination.
Among the various treatment methods for mercury decontamination, I'll be explaining about 2 significant treatments for mercury decontamination of solids. The first method is solidification and stabilization, which is used to treat soil and sludge contaminated with mercury. Let's take a look at the working principle of this treatment method. Solidification and stabilization are techniques used to remediate soil or sludge contaminated with mercury by mixing solidifying or stabilizing agents to reduce the mobility of contaminants in the media. Solidification involves the injection of solidification agents such as cement and phosphate to enclose the contaminants into a solid material. In the stabilization process, chemical reactions are induced between the stabilizing agent and the contaminants to reduce their mobility. It involves mixing soil or waste with binders such as Portland cement, sulfur polymer cement, sodium sulfide, and calcium polysulfide to increase the binding power between the contaminants and the soil. This mixture is then allowed time to cure into solid form to prevent the spread of contaminants. Next up, let's take a look at another treatment method known as soil washing, which is used to decontaminate soil filled with mercury. Soil washing is a technique used to remediate mercury-contaminated soil by separating contaminants using a washing solution and mechanical friction. It uses a combination of physical particle size separation and aqueous-based chemical separation. The selected contaminated soil is transferred into a washing tank. Then, the contaminated soil is mechanically mixed with the washing solution to separate the contaminants from the soil. The contaminants are preferentially adsorbed onto the fine fraction of the soil or sediment. This process thus concentrates the contamination down to the finer particles to immobilize the contaminant. The residual material is then filtered from the contaminated washing solution, dehydrated, and disposed of in a landfill. The next few treatment methods will be explained by my colleague Shamini.
Interesting. Alright.
Well, now I'll be explaining regarding the other treatment used to treat water contaminated by mercury. The first method is precipitation or co-precipitation method. This method is generally used in large technology to treat groundwater and also wastewater contaminated by mercury. This method will reduce the concentration of mercury to be less than 2 grams per liter. The dissolved contaminants will be converted into insoluble solid. Later on, the solid will be separated from the liquid phase through clarification or filtration. Basically, the method of precipitation and co-precipitation uses various combination of chemicals and methods.
One of the chemicals used for this method is sulfide. In sulfide precipitation, mercury ions in solutions can be precipitated easily using hydrogen sulfide or alkali metal sulfide salts. In this process, sulfide is added to the waste stream to convert the soluble mercury to the relatively insoluble mercury sulfide. This figure illustrates the model of a precipitation system.
Well, now let's look at the second treatment used to treat wastewater and also groundwater contaminated by mercury. The name of this method is absorption method. So in this method, the wastewater will flow through a fixed bed of media and the absorbent will be packed into tiny columns. So when the water flows, the contaminants will be absorbed by the columns And once the columns become filled by the contaminants, it has to be replaced or regenerated so that the process can occur continuously.
Absorption is the process which occurs when atoms, ions, or molecules from a gas, liquid, or dissolved solid stick to a surface. In the case of water purification, water consisting of all its solutes pass through a column containing active carbon. Active carbon is utilized as it has an incredibly large surface area per unit volume, making it suitable for this process. As the water flows through, all nonpolar, less soluble in water particles stick to the surface of carbon, hence being absorbed. Water flowing out does not consist of these solutes, hence purified.
Now let's move on to the final treatment method, which is membrane filtration method. Membrane filtration method passes the water through a semi-permeable microporous membrane to concentrate the contaminants into smaller volume of water. This technology separates the influent stream into two types of effluent streams.
This picture illustrates the model of a membrane filtration system. The effluent stream is the fluid that passes through the membrane. The reject stream contains water and contaminants that have not passed through the membrane. The reject may be recycled back through the membrane filtration system to further concentrate the contaminant and reduce the volume of reject. If the concentrate is not recycled, further treatment may include processing in a filter press. When we observe the cross-section of the membrane used in membrane filtration, we can see that membrane filtration separates contaminants from water by passing it through a semi-permeable barrier or membrane. The membrane allows some of the constituents to pass through while blocking the others. There are 4 different types of membrane filtration processes, from largest to smallest filter pore size. The first type is microfiltration. The microfiltration membrane rejects particles as small as 0.03 microns as compared to a multimedia filter, which can filter out particles as small as 1 micron. The second type is ultrafiltration. Ultrafiltration has smaller pores than microfiltration membranes and can reject particles as small as 0.01 microns, which includes most viruses. The next type is nanofiltration. This has even smaller pores and can reject ions such as calcium, magnesium, and nanofiltration can be used in water softening applications. Finally, the smallest pore size goes to reverse osmosis, which remove essentially all organic and inorganic contaminants and produce contaminant-free water. And as you can see here, it will only allow water to pass through.
Interesting.
In conclusion, there is sufficient evidence of significant adverse impacts of mercury and its compound on global scale. There should be international action to be taken to reduce the risk of mercury to human health and the environment. It is important to have better understanding of the issues, but it is not necessary to have full consensus or complete evidence in order to take action. That's all from Breaking News for today. Thank you.